My name is Justin Modi, and this is my EECS-1021 final project. Let's start off with some main components. This is my safety key, which is my additional. This is the Grove board that is connected to my computer that has the code running on it. We have my water reservoir and pump here connected to the 9-volt battery, all connected to a MOSFET in the back, and then the plant, of course, with the moisture sensor inside of it. We can see that the safety key is in and the soil is relatively dry. Now we can run our code. Our code is now running and initializing. This pump will go for 5 seconds. We can see that in the first run, the code went from dry to wet. For goal 1, I tested my project by checking both hardware and software parts step by step. I used Boolean, true or false checks to confirm that the pump, sensor readings, graph, and emergency buttons were all working properly into my liking. For CLO Goal 2, I showed object-oriented programming through abstraction. Instead of putting everything in my main method, I separated the project into different classes. My classes are separated into different components. For example, the OLED is separate from the pump logic. This made the code a lot cleaner and easier to manage. For Goal 3, I used Fermata4j and Standard Library because they were an appropriate fit for my project. Fermata4j allowed Java and Arduino to communicate so things like the emergency button could work, and Standard Library was used so I can update my voltage graph, which made the system easier to read. For Goal 4, I stored my sensor data in array lists before graphing it. This was useful because it let me keep all my readings over time instead of rewriting over the old values. It also made the graphing a lot easier to understand. For Goal 5, I used state machines based on the soil sensor values. The code checks the sensor reading and decides whether the plant is dry, needs water, or is wet enough, and then performs the correct action by running the pump or not running the pump. It also checks safety conditions like the emergency stop button. For Goal 6, I improved by solving logical errors. One of the main issues that I ran into was with the state logic for the safety key. Even though IntelliJ showed that I had no syntax errors, the program behavior wasn't fully correct. To fix it, I made a flowchart of the decision process, traced it back to each steps, and found the logical issue, and it was a simple correction from there.